Hi, welcome back to Mrs. Barnett's Math Moment. Today we're going to take a quick look at a clock. So this is a clock with just the minute hands showing. You could look at this as the hour, 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, 5 o'clock, 6, 7, 8, 9, 10 o'clock, 11 o'clock, and 12. Okay, those are the hours. If I were to do this and I had a little hand going here, it's pointing to the dark number. And the minute hand could come all the way up, and that would be 1 o'clock. Or perhaps it is coming down to this, and that would be 1:30, right? So would like to clear all that off and start. I wanted to talk about the clock in the sense with fractions. Okay, so we also often say it's 2:15, or it's 2:30 something, and I'd like you to see the fractions that make that up. So there's 1/4 of the clock, 1/4. It should take 4 equal parts. 4 equal parts. Sorry, the mouse and my hand aren't working so great quickly today. It'll be 4 equal parts, and right now I have 1 of them. Can put another one in there. Suddenly I have 2 out of 4 equal parts. It would take 4 parts, equal parts, that's what fractions are always equal, to make a whole. To make a hole, not a hole like a hole in the wall. That would be HOLE. That is like a donut hole. We're not talking that kind of hole. We're talking this type of hole, WHOLE, which coincidentally is why our spelling system, people sometimes think it's odd that why is there a W, why not a W, whatever. It's because there are spellings sometimes differ so that you know which one you're talking about. If it's a homophone, meaning the phone, the sound that you hear is the same, but their meaning is different. How do you distinguish them? By their spelling. And it's quite possible to put a WH and say whole. We can do that. Who, words like that. It is very common as a way to spell. I'm guessing, I haven't looked it up, but it very likely goes back to Old English as well. But I would be a total guess. I don't have time to go look that up. So at any rate, we want to know the whole thing. If I were to divide this into parts and shade the stuff I would have all of it. Okay, so it's the entire thing. So far we know that 2/4 is this size. So if I go with 3/4 or 3, another word for fourths is quarters. You can think about money. This also relates to money. There are 4 quarters in a whole dollar. So this could be 25 cents. If this was money, that would be 25 cents, and 4 of them would equal a whole. The whole can change. So when I'm talking about 4 quarters in a dollar, my whole amount is worth 100. So every quarter is worth 25. But here we're talking about making this whole amount worth 60. So there's 55, 56, 57, 58, 59, 60 minutes in an hour. So this 1/4 is worth 15 minutes, because every 15 plus 15 is 30, plus 15 is 45, plus 15 is 60. So it took 4 equal parts, 4 quarters, to make a whole. Well, 2 of those quarters, 2 quarters, is worth a half of 60. So in this case, half of 60 is 30, and you can clearly see that we started at 1 or 0, and you count all the way to 30. That's a half. So we have options to break up whatever our whole number is. We can break it into different equal parts. Took 4 equal parts to make quarters. In this case, we're now on halves. Okay, so I can put another half up there, and the whole thing would be complete. I think we could also do sixths. Oh, 3/6 is worth a half. So if it's 3 out of 6 equal parts, how many more am I going to need? You're right, 3 more. 1, 2, 3. So all together, in a fraction, if I had 6 equal parts over 6 that it takes to make a whole, how much do I have? 1 entire thing. And earlier we had 4 out of 4 equal parts. That is also equal to a whole. Okay? 2 halves is equal to a whole. So you can make the different types of fractions this way. I'm not sure if eighths are going to do it. We'll find out. 1, 2, 3, 4. Oh, yes, we got to the halfway line, right? Remember, that's our halfway line. So if there was 4/8, how many eighths is it going to take to make a whole? What's half of, we said 4 was half of 8, so 4 more is 8 out of 8 parts is going to make a whole. Let's keep going. 1, 2, 3, 4, 5, 6, whoops, it started again. 5, 6, 7, 8. There we go. Tenths, let's find out. 1, 2, 3, 4, 5. Oh, yes, we're going to be able to do that one. Well, if 5/10 is a half, 5 more is 10. So 10/10. Whenever the numerator is equal to the denominator, you're going to get a whole. Numerator means the number of them that you have. Denominator is you are naming the parts it would take to make a whole. So we can keep going. 6, 7, 8, 9, 10. Wonderful. So we could make it with 12/12, 10/10, 8/8, 6/6, 4/4, and 2 halves. Now let's just for fun try the fifths. 1, 2, 3, 4, 5. We did it. So we also had 12/12, and we had 5/5. Well, let's see if we can do thirds. Are you ready? 1, 2, 3. Exactly, because each of these will make a whole. So 3/3 will also make a whole. So 5/5, 12/12, those are all equal to 1. I could put every one of these in one number. They're all equal to the same thing. Okay. Quick math fact there. And this is just like the clock. So let me clear everything. Do a quick recap. This is the minute hand on our clock. So let's use green. Okay. If my small hand points up here, I'm actually out to the hour hand. Okay? So the other thing is the minute hand, and the minute hand is what we were just doing. We could be at this, and the hour would be 1, and you read the inside number, 15. 1:15, or 1:30, or 15 minutes. We know there's 15 minutes, 5, 10, 15, until this clock, the minutes reach this hand. The minutes are going to go around every Every hour it's going to take 60 times to go around. And once it's gone around 60 times, it's a new hour of the day. Okay, quick lesson on clocks and fractions. Thank you very much for joining our math moment.